For this second part of this first event, as promised, we have Amandine David here with us, her loom, and one of her pieces hanging there in the center of the stage. Let's call it the stage. Amandine, as I was saying, is a designer and a researcher whose practice is focusing on traditional craft and digital practices. She's gonna explain us what she means by that, the relationship between crafts and digital technologies through her work that is exhibited at Order of Operations. So, with no further ado, I leave her the floor, and thank you very much.
My work is located between traditional craft and digital manufacturing. And so before introducing you to the Weaving Code project, I wanted to tell a bit about other projects. So to tell you about my interest of communications between different techniques. The first project is Crossing Parallel. It was my graduation project at the Design Academy Eindhoven. And it's a project where I wanted to kind of question the definition of craftsmanship, and is it about really tools or is it more about postures? And I wanted to initiate a dialogue between different techniques that could seem opposed at first. And so I started a collaboration with Esme Hoffman, a basket weaving master, and Joris van Tubegen, engineer and 3D printing inventors. And together, the three of us, we explored the parallel existing between coiling and 3D printing. And so coiling is a basket weaving technique that is somehow similar to 3D printing because it has the same construction principle. So it's the same idea of having one filament laying on top of each other on a horizontal construction. And so that was kind of our pretext to initiate this collaboration. And so I started with building a lot of models, mimicking those techniques, with the idea of trying to bridge the two techniques, doing pieces that would both involve basket weaving and 3D printing. And my goal was really to use those pieces also to communicate with the craftsmen, because usually the relation between designer and craftsman is more like a designer will be involved in the conception and the craftsman more in the fabrication. But with Esme and Joris, we worked all three of us from the start of the research. And so rather than giving them drawing, I shared models to raise questions and collect so we could raise ideas together. And those models were also constituted in a kind of archive. The goal of this archive is kind of to map the different trials and also to map the creative opportunities that could be continued, because in a design research there are a lot of ways we don't explore, but they are there maybe for others to continue. And so that was some outcomes of our collaboration. So we created a collaboration, a collaborative production method that involved both our three knowledges. And so it started with the hack of a printer to make it a rotary printer. So usually a 3D printer works on 3 axes. So there is the X, the Y, and the Z. And here we hack the Y to make it a rotary axle. And so this was a way to challenge this horizontal layering that was common to the two techniques. And also, then around this axle, we were putting a mold. And the mold was making the link between the 3D printing and the basket weaving. As Esme, when she's weaving, she's also weaving around molds. And so she would weave around the mold, and then we would put it in the 3D printer to kind of continue the construction of the object with 3D printing. And from this collaboration pattern, we produced some first pieces, and it's still in development. We are still working together 3 years after. And we are also keeping on exploring this archive that we call a library of failures to kind of continue on the opportunities that we can find in it. Another project is Keepercat, is really more based on the traditional craft. but maybe it will tell a bit about this interest of mine of languages and communication possibilities between different technologies. This is a project I developed during the Art Peace residency in Nuuk in Greenland in 2017. And I worked with Kim Kleist Eriksen. He's a Greenlandic bone carver. And yeah, he worked with like tusk, reindeer antlers, like really like animal materials that come from the Greenlandic territory. And so it taught me a bit of his knowledge, and through learning, yeah, the learning process was both manual, but also it was a lot of conversation. And one of his saying was like, okay, if you can draw, you can carve. And carving was really also his way of expressing himself. And we started talking also about, yeah, this place that were of carving in the Inuit culture. And that is really a medium of communication. And that is true for bone carving, because it was also used to represent tupilaks that are the evil spirits that they believe in and that they construct, and it was a way to represent it to like newcomers. And also there is a practice of like carved maps, and so those are maps to describe the shores and the islands around in Greenland. And instead of like reading a map as we are used to it on a flat surface, then those maps are like meant to be touched and so on. And yeah, this kind of things I found really fascinating. And also the Inuit language is a language that it was not written. It was a really oral language that was based on transmission of history and ideas through talking. And the way it's built is it's a construction of assembly of images to raise meanings. And so we shared some example with Kim. Like, for example, the way to describe object would be like the water pot would be like the place where to store water, or the cup would be like the object from which you drink water. And it's like this with a bit of everything. Like the table is like the place you gather around, or the seal is like the things that jump out of water. And all those images are like really poetic and evocating a lot of pictures. And so with this idea of assemblies of images and also like non-written languages, this led me also to question my tool of communication as a designer, usually using more drawings and talkings to share my ideas. And I started working with Lena Augusta Olsen. She's a ceramicist. And to work together, what we did is that we developed a carved language. So to work with her, instead of giving her drawings, I would give her like those 3 carved pieces and made on this language that we built together. So the idea was that here it would say either if it's a place to store something or if it's to drink something from. And then it would describe like, so the dots were water, and either it was this amount of water or a little less amount of water, for example. And this would say more about the shapes, like the different modules that I imagine. So I kind of had ideas of objects in mind, but I also wanted to leave it open and to see what would come out of it. And so Lena read those figures, those bones that were our dialogue. And from that, she drew a collection of ceramic objects. And so, as the interpretation of the phrases, the carved phrases is kind of free, then from one piece and one guideline, let's say, she could develop a lot of different pieces from it. And what was also interesting is that she took inspiration of this carved language that was the art of our collaboration, also to engrave the pieces itself, and that also raised the name of the project Keepercat, which means engraved. And voila, so that was more to tell you about my practice in between traditional craft, digital manufacturing, and focusing also on how we communicate between practitioners and between different technologies, between different techniques. And so the project Weaving Code, as Camilla was saying, is now presented in Bozar. And it's started as, almost as a joke, like we were invited at Design Academy to work with Arduino and to work with such tools and like, yeah, kind of making a code project. And coming from traditional craft, my reaction was a bit like, no, or like, why would we do that? Why would I already choose a medium before knowing what I want to do? Why should I not first start with a question and then see which medium I would use, maybe Arduino or maybe something else? And my mentors, they called me a Luddite. And so Luddites, they were, maybe you know, they were textile workers in the beginning of the 19th century, and they were weavers. And when the automated loom arrived, then they started losing their jobs because first, to manipulate a loom, industrial loom, it requires a lot of persons to manipulate it and to code the different patterns, like to put the thread in the right position and so on. And so their knowledge had a lot of value. But with the arrival of the automated loom, then they kind of, yeah, the work lost a lot of value, and a lot lost their jobs. And so what happened is that the Luddites, they gathered and they started breaking looms and putting factories on fire. So it was really a violent fight. And somehow I still had this idea on mind of like opposition between human knowledge and human craft and the machine that would replace humans. And also working with this idea is like, yeah, the question of like what tool is used, and is it really a matter of tools or is it a matter of postures? But so I decided to embrace this posture of a Luddite, and I started weaving. I never wove before. And I got quite fascinated by the language that is used for like draft patterns, and started to investigate weaving as a technology. And as Anne was saying, I discovered quite quickly that actually like punch card and the automation of weaving was the ancestor of computers. So I was kind of fighting against new technology, but also I was part of it and I was using it. And I found this connection quite interesting, because also like punch card, they were like a way to make it easier and to avoid mistakes. But it was also, as designer, I see it also as a way to reproduce the same pattern over and over, rather than being behind a loom and just like weaving, following our intuition, for example. And so, yeah, weaving being the ancestor of computer, I realized that, yeah, those weaving patterns were also a binary code. It's a binary code because when I weave, the thread that I pass on is going either under or over a thread. So the threads, they are either ups or downs, and that's a binary action. And so that is, yeah, the binary code of weaving. And yeah, and like opening different books, I realized that, yeah, it's considered a lot, it was still considered a lot like as a domestic craft and even feminine craft, but it's written as coding, and it has some similarity with coding and with programmation, because you set up an environment, which is the warp, like the thread that is already on the loom, and then you have potential action that comes as a loop, that are the patterns that you can weave or not weave. And so, yeah, to illustrate, yeah. So here, for example, is the warp. So is the way I settle my threads. So there are like 4 frames, as on this one, for example. And so each thread is attached either on the frame 1, 2, 3, or 4. And then the way I will weave, it will generate a pattern. And so, yeah, for example, with this very simple 1, 2, 3, 4, 1, 2, 3, 4 pattern, I generate just this simple pattern. But if I start changing the way I set up my warp in the beginning, if I would have set it otherwise, then the whole pattern, the whole action that I do afterwards, I modified with it. And same, but once my warp is set, then I can also modify the patterns that I weave and like following what I want to do and reacting on the previous patterns, I can decide for the rest. So it's really a combination of like one context and then the data, let's say, that I put in that will give these patterns. So it's this kind of mathematical pattern. And so those are examples of weave. And they are like geometrical patterns, but they also have implications. They have a physical reality, and they have a history for some. Like, for example, if we look at satin, satin is a certain weave that is mostly used for silk, and that as it's very open, like the thread in white like will be a lot in the front, so that is used like to reveal the shininess of the threads of silk, for example. And also satin, the name of the draft pattern, is also telling about the history of silk thread, because satin is silk was coming from China through Arabic countries before arriving to Europe. And satin is actually coming from zaytun, which was the Arabic name of Kwanzu. And so it's telling about all this travel that the material was doing. So yeah, I like the idea that behind mathematical abstraction, there are actually a lot of histories and implications. And so yeah, so now I have my language that is this binary language that is used both on my loom and that I can also use on a computer. And so yeah, so that's how I started hacking my loom to communicate with my computer. But I was also wondering, okay, what should I communicate with it? And as we can do anything with computers, what should I do with it? Why connecting it to it? And going back to the reality of weaving and why it would be interesting to mix computer and loom actions, I focused on those two codes that have a physical reality because they create openings in the weaving. And so when I weave it, then the computer will recognize that a hole is appearing in the textile, and that in this hole it can start generating a piece. And the longer I weave these same patterns, the longer the opening is, then the bigger the piece that it will generate will be. So now, as you may see, like my second frame is up. I mean, the pedal is down, so the frame is up. And now this is what is shown on the screen, and then it will continue detecting what I'm weaving. And so this is simple wave. Let's see that. And so we can see like both appearing on the kind of the pattern, both on the screen and on the actual textile. Slowly. So let's see that now. Now I'm going to start like creating a weaving and opening. So the fourth shaft will always stay up. We can see the line appearing of the fourth thread. And it's the fourth shaft is the one with the black thread. It was a way to highlight also on the piece this code. And so now it's starting like, to generate a piece that will grow as far as I weave. And we can see a bit the opening that is like kind of a double weave. I mean, not yet a double weave, but where the piece will be. Now I'm closing it, kind of. So now he detected that I'm done with the opening. And so he missed it, but he went from red, where it's always growing, to once it's gray, then it means that it's finished growing it. And voila. So now it's recognizing basically two patterns, the simple weave and the one where either the fourth thread is always up, creating an opening on the top of the weaving, or either the fourth thread is always down, and thus creating an opening underneath. But yeah, that is just kind of the start of the language that I'm building. That could be like augmented with different waves, and then associated with different shapes and different meanings. Also, it depends in relation to the meaning of the draft patterns themselves. And so here is the beginning of the exploration that is on Shona at Bozar. So there are abstract pieces, like telling more about this language and combination of techniques. And voilà. Merci.
You know the drill. If you have any question, yes.
When you said that you had the machine, what exactly did you do to the machine?
Okay, I need to. The question is, what did you do to the machine?
Nothing bad, I swear. So with my basic skills of Arduino, what I did is setting up this small display that is just a series of end switch. So it's like on-off. And so from this on-off settings, it can detect like either if it's up or if it's down. And then let's say that, the code is basically something like this. Like if it's, now it's off. So if it's off, it's down, so it's 1. So if it's off, it writes 1. If it's up, it writes 0. And then it gives me this series of digits, of 4, 0 or 1s. And from this series of digits that is coming constantly, then I worked with someone with way more skills than me, Sebastian, that then from this information coming from the Arduino is using it within Rhino with a grasshopper to generate the shapes.
So there is the steps, the chain of communication is from your hands, therefore the loom, to the Arduino, to the computer, where is a software that communicates to the 3D printer, basically. These are all the steps.
Yeah, they can be 3D printed. Yeah.
Okay. Yes, please.
So it means it's possible to have like a two-way communication, because in that sense you could also like improvise patterns and in that way train an algorithm, but you could also receive information from the algorithm to tell you what to do. So you could train the machine to learn something about the pattern that you're creating based on improvisation or some other knowledge language.
I can't repeat that.
Yeah, you were saying that I could either like talk to the machine or learn to the machine to talk to me, kind of.
Yeah,
if I
it could be a two-way communication in that sense.
Yeah, I think that in the way I work and I came to the project was with the idea of using tools to augment a craft gesture and using and keeping the kind of location of decision within the intuition of the weaver, kind of. But yeah, so that I would rather keep it like human telling what the machine what to do rather than the opposite way around. Yeah. That was, I mean, for now, we never know.
Any other question?
I don't know, would you like to give us a demonstration near? I would actually like to
try
see
it?
Or see it closer.
Yeah,
Because
we can start again.
We can definitely do that. I mean, we can do that now, unless there are any other questions. There is a little thing that I find very interesting, and it's something that we mentioned in previous conversations, and is how in mainstream culture, we, especially in the Western world, first world, we locate craft, traditional craft and digital technologies on a sort of straight line, on the line of time, and crafts seem to belong, are perceived as belonging to the past, something that is heritage, something to be preserved, but as it does not belong to the present anymore, and definitely do not belong to the future, while everything that is digital, it's like belong to the future. It's something that we are just starting now, and the future is digital. And there is this dichotomy, that two things that seem irreconcilable while they are intrinsically intertwined.
Yeah, there is a lot to tell. Yeah, that's true. And I think it's also shown in the exhibition when we see, for example, the origami master that is actually folding origamis also for NASA and military purpose for like parachutes. You say parachutes? Yeah. Or like I mean, maybe I don't know exactly the story, but I know that also from when in the US when they were like building the rocket to go to the moon. Mm-hmm. Like they also involve like weavers, like indigenous weaver in the making of how to call it, like those devices to store data, and those were made with weaving. So it's also there is knowledge to be taken from any craft, whether they're like weaving comes from like million years ago, but it's more like a perpetual movement.
Yeah. Okay, so if there are no any other question, I guess that we could get around the loom carefully and with enough distance, of course, from each other. Maybe not all at once. Okay. Then let's go for it. Thank you very much.